I'm waiting for that to decide it wants to download. Yeah, here we go. Okay. So exception handling. What is exception handling? An exception is when the program gets into a state that it cannot recover from. It's an unexpected state. It's something like you were trying to write to a file and the file doesn't exist, so it can't open it, or you were trying to write to a dry path that doesn't exist. That's fine. Really? Process Explorer to the rescue, eh? Come on. Whimper. Kvetch. Alrighty. Camtasia Studio. In task. Ooh, and it disappeared as soon as I pulled up the task manager. What timing? Something's going on here. Alright. Anyways. Okay. Or you divide by 0. And division by 0 is something that your particular language cannot handle. So the program will generate an exception. And we've seen that before. Another one is null pointer. You create a reference to an object, but then you do not actually create the object with a new keyword, and then you try to reference one of its members. It'll blow up on you. It'll give you an exception. Exception handling is when you use try-catch statements in order to catch the error. And then once the error is caught, you can handle it in whatever way you need to do, and then the program doesn't, just hang there with that ugly error message. You can make it handle these errors gracefully. If they type in a file name that doesn't exist, you can prompt up, please re-enter file name. Or if they try to type in an integer, but they give, some alphanumeric input, letters and stuff like that, and the conversion fails, then you can tell them, hey, that did not work. So that'd be a good example to do. I'm going to write a little bitty method called getInt. My requirements are that I really want it to be an int. If they type in something else, I'm not going to accept it. In fact, it's going to blow up. We'll get an exception if they try to type in something else. So since I'm probably going to use the scanner amongst multiple methods in this file, I'm going to create the scanner as a class object, as a class member. So it doesn't have to be public, of course, but static scanner sc is equal to new scanner system.in. Add that class. Add that import. Never do create class. You'll litter your project with classes unless you absolutely know that that's what you want to do. But imports are fine, letting it help you with the imports. In Java 1, I have a lot of people that get real addicted to clicking on the red arrow and trying to make their problems go away. And then they wind up with something that's completely wrong because they've got 20 extra classes, in their folder that they created by clicking the arrow. Okay, so to get an int, let's print, enter an integer. Now let's try to read it in, but we're going to read it in as a string so that they can type in anything. And then we try to convert it to an int. So string s is equal to scanner.next. Now I'm going to convert it with integer.parseInt. Int I is equal to integer.parseInt, that string, and then return. Looks great, but let's invoke it. Yeah, return I. There we go. Int x is equal to getInt. And we really should print, a message saying what we're trying to get, but enter an integer is enough to demonstrate this. So if I run it and type in some valid input, we're going to get some good input. I may as well add a print statement down here to print out what x was equal when we were done. So it churns, it churns, it churns, it churns. It says enter an integer. I type in 10. Cool, the program's done. But I run it. I type in a floating point number, 10.5. And it blows up. So recently in the news there have been a lot of talk of, orbiting satellites and stuff like that that start spinning madly out of control. They start ejecting propellant for some reason or whatever. And who knows what's going on, but if you were writing a controller for a satellite, you would not want it to be able to generate exception errors, crash the program. If you're lucky, the computer might reboot, and I'm sure that they put fail-safes in there. But, or in a targeting program, your Patriot missile guidance system, whoops, I got an exception error because it happened to go at 0 degrees rather than 1. Whatever. You don't want it to do that. So we're going to fix this. We're going to rejigger our getInt function. And this is kind of a crude way of doing it, but it'll do it. I guess before I get too excited by it, I'll add the bare minimum. Okay. So try. I've enclosed all the code that can generate an error. Specifically, that's the one that can generate an error. That's the bad boy. I can move this stuff out of it, but I'll leave that stuff there. This is just going to be the simplest example. And then I have to catch an exception. If you're lazy, you can do this. Catch exception EX. Don't be lazy. Find out the exact exception that the failing statement can cause. And if I go and I look in my output, it tells me what the exception was. Number format exception. This is a catch-all. It would catch every exception, but you don't want to catch every exception. You only want to catch the exceptions that you're predicting because, exceptions are information. And if the program fails in a different way, you don't want your simple input, capturing that failure and then hiding it from you. Okay, so instead of exception EX, we're going to catch number format exception EX. And I'm just, as a habit, I'm calling all my exceptions EX. So let's print out not an integer. Now I'm getting an error here because it wants a return statement, and my return statement is hidden up here. So to fix that now, although this is really horrible programming and we're not going to keep it like that, I'm going to tack on a return -1 at the end. So I run it. It says enter an integer. If I type in something good, it prints that out. I run it again. I type in something wrong, like 1.5, and it says not an integer, and then it prints x is equal to -1. Well, we're halfway there. We've caught the error. It's not, causing the program to crash. But what we want to do is we want to loop over and over and over until the user types in something good. So we're just going to enclose this bad boy in a while true statement. We're going to loop over and over and over until they type something good. Now, rather than re-indent everything, I just indented my while statement too. So, my indentions are kind of tiny. That got rid of the need to enter a -1. Maybe you see why. What is the program flow? Let's do a good data first. While true, okay, we're in an infinite loop. We're in trouble. No, we're not in trouble because we have a return statement here. We could also put a break statement here that would serve the same purpose. It would get out of our infinite loop. So try. Print, get an integer. Get a string. Call parseInt on that string. If it works, we return. Boom. Everything worked perfect. They type in garbage. What's going to happen? We print, enter an integer, we get that garbage, we try to convert it, that fails. That throws the exception. So this return line isn't even executed because immediately, it's like a go-to statement, it runs to the catch. And it prints out this error, not an integer. And then it hits the end of the loop. Well, we didn't break out of the loop or return out of the loop, so we're still in our infinite loop. We come back up here and we repeat this again. And we keep doing that over and over and over until we succeed in this parseInt statement. And once we succeed in that parseInt statement, we can return and bail out. So now this will work. I hope this is working. Hope it's taping with the volume. One time I got a recording and a video and it didn't have any volume. Okay. So I run it. I'm going to type in garbage because I'm already pretty sure that good values work. 9.5, not an integer. Enter an integer. Now these are pretty terse error messages, obviously. You know, one A, B, C, D. That's not an integer. Enter an integer. Eventually, I'll get tired of trying to screw it up, and I'll type in a valid integer, and it returns that value so it can print it out. So I'm going to let the formatter, the source code formatter, format this a little bit so I can get more of it on the screen at the same time. Source, format, there we go. All right, hopefully that's pretty clear. This is a way of forcing the user to enter some input. Now you might want to provide a, or cue to quit the program or something like that. But this is showing exception handling. You put the risky code there, the code that can throw an exception, and you put a catch statement underneath it. And if the risky code blows up, it will throw an exception, which is caught. There's actually a keyword called throw. You can generate your own exceptions if you want. I could make an exception right here. This is silly. Don't type this in. But, exception E1 is equal to new exception. Wow. This is stupid, of course. And then throw E1. Now it's complaining that I'll never get to that one. What this complaint is unreported exception. It must be caught or it must be declared. I have to fix it in one of two ways. The reason it's not being caught is I don't have a catch exception here that matches that. I could add an exception here that would catch that specific brand of exception, and that would get rid of that error we were seeing. This is still saying an unreachable statement, but that's not really the point. That's one way to fix it, is to add a catch for that. The other is to come over here and it says add a throw clause. If you do add a throw clause, you're adding something to the method that says, oh, by the way, this thing can throw an exception. And that means when we throw this error, it's not going to get caught here. It's going to be passed up the system. The buck stops at the present or whatever. It would be passed back to here, and it would be up to this code to handle the exception. Notice we're getting an error here now. It says unreported exception. Exception must be caught or declared to be thrown. So we pass the buck here, so now we have to surround this and try catch. And that's a valid way of handling errors. If you don't want to loop until something good happens, you can just you can just catch the exception and then throw it out of here. And then the calling code, the client code, has to handle it. All right, I'm going to undo those changes. There's one more component of a try catch. And not all languages that do try catch support this. But this is going to be finally. This is the finally keyword. What finally means is this is stuff that has to happen regardless of whether there's an exception caught or not. So I'm going to add a finally clause. Feel free. System.out.println. And I'm going to put finally done, just to show where that happens in the program flow. And I'm going to add another print statement right before the print, or in front of the return. This is system.out.println about to return. So these are the statements I added. I added a print statement above return I that says we're about to return. And then I added a finally clause down here. Now a finally clause gets executed before you leave the try code or the catch code. If there's no errors, it executes, it jumps down here and it runs it. If there is an error after it does whatever is in the catch, it runs down here and it does it. And that creates kind of an odd program flow. It's like the oddest program flow that you can implement in terms of where the program runs. You'll see what I mean when I run it. Okay, I'm going to type in a good one first, 10, just to see the... All right, check it out. We typed in something. The conversion was a success. So that parseInt worked. This next line is about to return. It sure does print that. But then, whoops, before it returns, even before this return statement executes, it runs down here and it executes this finally code. And that is really not intuitive at all. That code, this finally done, is being executed between that statement and that statement with no indication, to the naked eye that it's going to do that. All right, well, that worked. Let's do it again. Run it with bad data. Enter an integer, 9.5. Not an integer. Finally done. Enter an integer. So what was the flow this time? Well, enter an integer. We got it. It tried to parse it, but the parse failed. What happens when a parse fails? It throws an exception. That got caught by here. So we didn't get to print out about to return, and we didn't actually return it. Instead, we printed out not an integer. And then we hit that close brace, but before that close brace was executed, whoops, we run down here and we do the finally code. And then we come back. I could do the same thing here. I could put a return statement in the catch. Watch. About to return a -1, and then I'm going to return a -1. Between that line being printed and between this return statement being executed, we're going to see our final message. So enter an integer, -9.5. Not an integer. About to return a -1. Finally done. So how did that happen? Parse int through an error. It was caught. It printed out not an integer. Sure enough. It printed out about to return a -1. Sure enough. And then it printed finally done. Say what? What the what? Well, it went down here, it executed that finally clause, and then it came back up before it issued that return statement. Again, that's weird. Not all languages support finally. Maybe this makes perfect sense to you, but like I said, not all languages support it. I don't think C++ does, and I think C# does. Was somebody about to ask a question? Yes, sir. Well, it's kind of like that return statement gets queued up. Oh, we're going to return now. We know that we're leaving the loop. So, it kind of jumps down to here and, oh, well, we're trying to leave our try-catch before. It's like it works like this. Java doesn't support labels like C++ do with goto statements. I think goto is completely disabled, and there's no way you can get it to work. And then I had an A here that, all it did was return whatever we wanted it to return. So what happens is when our return statement executes, it's effectively going, okay, well, I'm going to bail out of the entire procedure, so I'm going to run down here. And then, whoops, on my way out of here, I pass the end of my try-catch code. So I'd better execute my final. And it does that, and then it returns. Does that make sense? Yeah. Okay. All right, that's about enough about exception handling, I think. I could give more illustrations like divide by 0. We could catch, but divide by 0. But once you've seen, one exception handling, you've seen them all. Okay. There are two different kinds of exceptions, though. Broadly, there are two categories. If you look at the tree of the exception class and all the inheritances, there's like 10,000 different exceptions that Java can throw, but they all fundamentally come from two branches. One is called checked exceptions. Checked exceptions have to be handled or your code won't even run. And we're going to see that really soon when we start doing FileIO. FileIO throws checked exceptions. The developers of Java decided that FileIO is so risky that you have to implement the error handling code. They could have made the decision, no, you don't have to implement the error handling code, and if something goes wrong, the program just blows up, and throws an exception and it stops just like, our parsing did. But no, they've decided that in order to save you from your own lazy self, that you have to implement exception handling. That's a checked exception. A A checked exception is mandatory. Any code that can throw a checked exception has to be handled in your code. An unchecked exception is like divide by zero or a conversion error, a parse error, an arithmetic error. Yeah, it's a good idea to handle it, but they don't make you code it. And some people say, well, why did they do that? Why don't they make you catch absolutely every exception? I don't know. Would have made your code more complicated to develop. Every single time you called parseInt, you'd have to add, exception handling for it. Maybe you're pretty sure that what you just generated is an int, and you don't want to add exception handling there. Maybe, because it starts inflating the code. Our getInt function was pretty clean at the beginning. It was like 3 lines of code. And now that we added error handling to it, it's puffed up. It's huge. And often in production code, the error handling code outnumbers the line count of the productive code, which is weird, huh? Okay, so now let's do an example of some FileIO. I want to create an itty-bitty little class that we want to write to a text file. I'm going to call it student. Grade. Yeah, grade. And what does a grade have? It has a student name, which I'm just going to call sname because I'm feeling lazy. And it has a list of scores. I'm going to make the list an array list rather than anything else. Array list of integers. Nah, doubles. Scores is equal to new array list. And of course I have to, whoops, I got that syntax wrong. The diamond comes before the parentheses. Cannot find symbol, add import for it. Okay. I'm going to move this getInt code down below main so that I can try to keep main pretty close to that class that I just defined. You don't have to do that, of course, but when I'm scrolling up and down, I'd like for that to be close together. Okay, so here's main. Goodbye, getInt. We've tested you. Comment you out. All right, let's declare an object and put some data in it. Totally lazy. I'm not adding getters and setters. Okay. So grade G1 is equal to new grade. Now let's set the name of that student. G1.name is equal to Fred. And G1.scores, we have to add some values to it. Let's add 100. They made 100 on their first exam. Well, I'm blowing that. Because it's not add, it's append, isn't it? The last 3 times I've... Oh, come on. What am I doing wrong? Add. What am I doing wrong? Because I didn't add a double? Because I was trying to add an integer? Wow, that's picky. What do you know? Okay. So, he made 100 the first time. He partied before his second exam and he only made a 20. But he redeemed his final and made a 90. Or 80. There we go. Now we have an object. Let's write it to a file. I'm going to modularize this a little bit and create a write text file function that accepts a grade object. So I'm going to say write text file, and it's going to be called grade.text, and it's going to accept that grade object. So now we need to write a method that will accept a string, which is going to be the file name, and it needs to accept a grade object. So underneath main, public static void void. I should make it return some kind of error code, but I'm not gonna. Write text file. The two parameters, one of them is a string file name. And the other one is a grade object that I'm just going to call gr. Now, just to make write text file do something, I'm going to print the information to the screen. It's kind of too bad I didn't add a a toString method to my object. I'll probably regret that. So system.output.println name equals plus gr.name, sname. And then let's print out the scores. We're going to cheat on that one and use the ArrayList's toString method. Scores is equal to plus scores. Because it will, gr.scores. Now that's really kind of half-assing it, if you excuse my language. I should write a for loop that'll print each score out. And the reason that I should do that is because when I write it to a text file, that is what I'm going to do. But I just want to make sure that my structure works first. So I'm going to run it and make sure that it prints Fred and then a series of 3 scores. Because that's the default output if you print an array list, is it just, calls toString and dumps that out, which is at least better than printing the address of the variable. Now let's make write text file do something. To use a text file, you have to do 2 things. 1, create a file output stream, capitalize in the right place. 2, use that FOS to construct a printwriter. And then 3, issue printwriter.println or printwriter.print calls, just like writeLine and write, to write to the file. Then it's a good idea to close your file. It will close when the garbage collector, cleans that object up, that file output stream and that printwriter. But the garbage collector may wait a couple of seconds before doing so, and during that time the file would be locked. So we're going to close our file before we're done. Unfortunately, we're going to have to add all sorts of exception handling to get this to work. So file output stream FOS is equal to new file output stream, and I have to pass in 2 parameters. One is the file name, which I happen to pass in here. And then the second is a Boolean value which indicates whether we are going to append to the file or not. If you pass in true there, it appends to the file. If you pass in false there, it overwrites the file. False means overwrite, true means append. Now, of course, it's complaining that I don't have a definition for file output stream, so I'm going to go add the import for that. If all you see is create class, you know you've done something wrong. Unreported exception. Yeah, so we're already running into bad news here. What kind of exception could you give when you're trying to create a file? Yeah, you're trying to overwrite or append to a read-only file, or you're writing out to your A drive and you don't have a floppy disk in your machine, or your file name contains characters that the file system can't, whatever. I could immediately, start adding exception handling code, but I'm going to write the ideal version of this code, the code that you would write if you didn't have to worry about exceptions first, and then we're going to add exception handling to it. Okay, now we have to create a printwriter based on that file output stream. And by the way, you write to sockets on the internet in the same way. You can create a different kind of output stream that'll write to an internet socket. and then you can create a file, a print writer to it, or an object output stream, or whatever from that. And then printing to a socket, once everything is set up, is as easy as writing to a file due to the magic of the classes. Okay, so print writer PW is equal to new print writer, and pass FOS, our file output stream, in as the constructor. Again, I'm getting an error. The error, I'm going to get two errors. One is easy to fix, that's add the import. The other is that I'm surprised it's not telling me that there's an exception I have to handle. All right, so be it. I mean, what if you wrote and, oh, well, we haven't written yet. We've just created the object. We actually created the file at this step, and now we're creating an intermediary object that is going to manage output to that file. So that's why that one is not going to throw an exception, because the dangerous stage is when you actually do some file I/O. This hasn't done any file I/O yet. It's just creating an object in memory that's going to manage sending stuff to that file output stream. Okay, now let's write our data out. pw.writeLine. Let's write out that student's, except it's print. pw.println grade.sname. Still not yelling at me about exceptions. Perhaps it's wanting me to fix this exception before it starts noticing about the other ones. Okay, now we're going to also print line all the grades. But I don't want to just write it out as a single string like I did. I want to do a proper, you know, for every double score in the grade.scores object, print that score out. Print line that score out. And then let's close our print writer, or our file output stream. Let's do that. FOS.close. That one's giving me an error too. Okay. Unreported exception. I love this one. Can use functional operations. This turns our simple for loop into something that looks like Lisp or something like that. Don't do that. Okay. That was added in Java 8. Functional programming rather than procedural programming. Okay. So this would be great, except we're not handling our exceptions. I could start trusting it, you know. What is it offering to do? Add a throw clause? No, you don't want to buck the problem. Send it up to the calling code, the client code. Surround the statement with try catch. Surround a block with try catch. That would be the best thing, probably. I'm going to do it just to eyeball what it does. Oh yeah, but then it threw in a whole bunch of catches and finalies and stuff, and so I'm going to undo that. I'm going to put my try right here. And then down after my file output stream close, I'm going to put my close block, and I'm going to put my catch. But I have to know what kind of errors to catch. Let's see what it's complaining about file output stream. What kind of errors can it throw? File not found exception. So we have to catch a file not found exception. Catch file not found exception. That's going to be another one I have to import. Or we could just import java.io and get all the exceptions, but okay. So file not found exception EX. We're going to print an error message. System.out.println. You could actually print the contents of the exception, but that kind of error would scare a user. We want a plain English error. We're going to say could not open, and then plus the file name. Now we're halfway there. But there's one more exception. There's the FOS close exception. Unreported exception, IO exception. Now, you know what a lot of people do is they just enclose your close statement in an itty-bitty try catch of its own, and then they don't report anything. Because what is the user going to do if it failed to close? If it failed to close, it's because the operating system threw some kind of error, but you've already written to the file. But we'll be good boys. We'll go ahead and add a catch for FOS.close. Excuse me, for IO exception. So catch IO exception EX. And now I'm going to give one of those alarmingly generic messages, you know, IO error. And I have to add an import for IO exception. I'm going to move my braces up to collapse the code a little bit. Get more of it on the screen at the same time.
So each of these exceptions that are catching, that EX that were declared is looking to that catch?
Exactly, right. And I could give them different names, indicative, you know, of what kind of exception I just caught, but I didn't.
Would it work without the EX?
Let's find out. I don't think it's going to. What if I caught that and I didn't do anything? Nope. Nope. All right. There are warnings. Convert to try with resources. This is an interesting one. This is actually a good programming paradigm. Let's do it and then undo it. Okay. Check out what it did when I let NetBeans handle it. It created a different syntax, a more modern syntax for the try catch. What it did is it put try and in parentheses, and then it put some code inside that parentheses, which is really alien looking. I don't particularly like that, actually. But what that does is, if you do it like this, then the compiler is smart enough to close the file output stream on its own. You don't have to put in an FOS.close if you do that. I'm going to undo that. It makes the syntax much more difficult to read. I don't see any errors. I see those warnings, but it looks good. I'm going to go ahead and run it. It still has our print statements in it, I guess, because it printed out Fred and scores. Nowhere did I add a print statement that showed success, that we actually printed anything. So after FOS.close, I'm going to add system.out.println file written, and then put the file name, just for our edification. And if you need information like the size of the file, or the entire path to the file, stuff like that, you can manipulate the objects that Java gives you. They have methods for summoning up that kind of stuff. All right, so it says file written, grade.txt. I doubt this is going to work. I doubt I'm going to be able to come in here and type grade.txt and have it search the tree and accurately find it. But if I go in my NetBeans directory, I'll find that file. Okay, so that didn't work. Go out in Documents, NetBeans, Projects. My most recent one is Java Application 13, and there's my grade.txt file. I open it up. Oh, and there's nothing in it. Well, throw me for a loop. We didn't get any exceptions. I printed the name out. That's going to be a real bummer. I will mention that. So the problem was that we were not closing the printwriter before we closed the file output stream. So to get our code to work, I had to add the pw.close before the FOS.close. That fixed that. Now we're going to write a new method that reads a text file, builds a grade object, and returns that grade object. type this and see if I get it correct or not. Okay. File. I don't think this is going to work. Let me hit the PowerPoint. That's what it's there for, huh? That's pretty cool. This version of the book shows reading text from a website. I like that. Really? We can create a scanner just with a file name? I thought we had to pass it a file object. Okay. We'll give that a shot. Scanner file in is equal to new scanner, passing in our file name. It's not even yelling at me about exceptions. Let's keep going. Now we need to read the student's name, and then we need a for loop that's going to read all of the integers out of it. So string name is equal to file in dot next. Reading from a file with a scanner is exactly like reading from the keyboard, except that it can throw more exceptions. To make things easy at first, I'm just going to read one value out of the scores rather than write the loop that's going to do that. So I'm going to just write something called double D is equal to file in dot next double. Then we can print those two values, or let's create the grade object. So gr.sname is equal to the name we just read. I don't even have an array list built. Let's just print that stuff. System.out.println, their name, plus that score we read, D. Now I'll be real surprised if it works this cleanly. We're not issuing a close or anything like that. No, we didn't put a call to read text file. So go up to main, and after we've written the file, we should be able to read from it. So grade G2 is equal to read text file, and then pass in the same name. It blew up. No such element exception. Usually you get that error if you try to read from a file and you hit the end of line. That's what I thought. I thought you had to create a file object. Okay. So instead of just trying to pass in the file name to it, do this. File FO for file object is equal to new file. Pass in the file name. They'll probably complain that we don't have a class called file, so I'm going to add the import for that. It's also going to complain. Complaining bitterly about that. I thought I added import for Java. Okay, I did. I did not. That was the error. Okay, unreported exception, file not found. Same thing. We're going to have to enclose this code in a try-catch block. So, just right up here, try, do all this stuff, catch, file not found, exception, EX. And the reason we're having to implement these is because they are checked exceptions. System.out.println, could not open file, plus file name. And if that happens, we need to return something. But I don't know about returning a great object with bad data. So instead, I'm just going to return null. Kind of bad programming, but it'll fit the requirements of this particular method, which is try to read something in. Then your client code would have to handle that. You know, if you issue a call and you get a null return value, then you know that the file did not exist. Because what are you supposed to do? You know, the file didn't exist. What kind of... You could ask for a new file name. That'd be about the best you could do. And you don't want to ask for a new file name inside of a utility function. Okay, so it opened my file, and it read the user's name, the student's name, and their first score. So we are 9/10 of the way there. Let me remove these blank lines to get more of the code on the page at the same time. Okay. But what are we going to have to do? We have to loop now and read all the scores in. And we didn't encode a sentinel value. You know, we didn't write out a -1 to indicate that there was more data to read or no more data to read. So we're just going to write a loop, and then whenever we get the exception that indicates the end of file, then we're going to bail out of the loop, and we're not going to treat that as a file not found exception where we return a null. We could do it a little bit more elegantly than that, but okay, here we go. So instead of double D is equal to fileIn.next double, we're going to need a separate try for this code. But before that try, let's go ahead and create our array list of scores. No, let's not. Let's use the one that's already built in the grade object. Okay, so try this. Double D is equal to file.next in double, and then gr.scores.append that value to it. And we're just going to stick that inside a while true loop. And that's going to be a problem, obviously. It's going to want to read forever. There's a specific exception we need to handle. I don't remember the name of the exception, so I'm just going to comment that out. Really? It's not append, it's add? Okay, gr.scores.add. Unreachable statement, yeah, sure enough. Okay, there's a lot of garbage I'm having to do in order to get this to work. We saw that error earlier. It was no such element. So let me just Google that up. No such element Java exception. You'd think it'd be something named a little bit more elegant than that, like EOF. Okay, so here's our try. Here's our code that reads from the file in an infinite loop. When we hit the end of the file, it throws an exception. No such element. And that's totally cool. We don't care about that particular exception. That is expected behavior. Now there are other things you can do. You know, you can issue a has more data call on that scanner. to see if there's any more waiting data. And if there's not, then you can bail out of it. That would be cleaner than what this is. This is just kind of a brute force handling of it. Okay, so we print out the name, and then we're going to print out the grade list, gr.scores. And I realize that just kind of probably made it difficult to follow. This is our try loop now. Excuse me. Right underneath grade gr is equal to new grade, we have all this code. So what we inserted was this. We inserted this try, this catch. The catch doesn't even need to do anything because it's just what is invoked when we have an end of file. And then we copy the name that we read into our grade object, and then we print out that name and the scores. Yeah, we should. I'm cheating. I'm printing the object so that it'll print, the list, and we know that it worked. And in this case, it did. We had 3 scores that we had written out, and then by the time this thing is done, we read in 3 scores. The cool thing to do really would be to take that code out of the read function entirely, because you don't want to write chatty utility functions, that start throwing stuff on the screen. This line here should be in the client code. I'm going to do that. I'm going to cut out the system.print line. Raising your hand to her. Okay. And then we will spend the last few minutes of class. I'll wander around and make sure that everybody has gotten this to work. And let's make a Dropbox for you to put this into. Okay, so after I read the file in main, I'm going to print line gr.sname followed by g2.sname followed by g2.scores. That's where the print ought to be. Okay. So it's kind of a lot of trouble reconstituting an object, especially if it was a complicated object, something more complicated than just a name in an array list. It could be a very complicated object. And it could be a character in a video game that has 100 different attributes, and the list of weapons that he's got and stuff like that. So the better way to handle that is to use object output stream and object input stream, where if you construct your object right, you can issue a call to write that object out in one fell swoop, and boom, it's done. Or you want to read from that file. You issue one read call, and it completely rebuilds your object. Now, there's some kind of drawbacks to that, which is that what you're writing out is a Java-specific file at that point. You could not then turn around and write a C++ program that would parse that data pretty easily. Whereas, text files are, everything understands what a text file is. You could write a Commodore 64 app that would, open your text file and send it to a line printer or whatever. Okay, guys, everybody get this working? I know that we jumped around, and so it's very plausible that you...
I was going to ask if you could scroll down to where we can see the read text file on the screen.
Yeah.
But that's where my problem is. I don't know what my problem is.
Okay. You can't see the last 2 things in this if I get all of this on here, but all it is 2 closing braces.
I've already copied that.
Okay, cool. Yeah. create the Dropbox for it. So those who want to bail can. Refresh your Dropbox, you'll see in class F. Go ahead and give me your .java file, or